So this last week for the BB8, I got in his new propellers and the motors. So I'm going to start this video off with a test of those and make sure we can get off the ground with them, make sure they deploy right. Then I'm going to go into some of the CAD. I'm going to show you the 3D printed door hinge. It works quite well, still need the servos for it. And finally talk a little bit about some issues I had printing, resolve them with a heated build chamber. Okay, so set up the new motors and a new 17-inch folding propeller. I've got a Hall effect sensor to measure RPM. This guy's measuring RPM, current, voltage, thrust. Got my 6-cell battery here. That is acting as our shunt resistor, which is why this is measuring voltage, not current. And this is controlling the PWM to control the ESC. To run this thing, I'm going to slowly bring it up to full power, record all the measurements, and we should have good stats on this motor propeller combo. Here I have T-Motors chart for the specs on their motors, the MN5212 KV420, which I have, and here's the stats I got off of my thrust test jig. Now at 50% they're saying they're getting 1.8 kilograms of thrust. Closest I measured, I have a measurement of, is 1.6 kilograms, and that was 10 amps at 250 watts, and they're measuring about 10 amps at 250 watts. Some 200 grams lower than them, so that could just be differences in the propeller. I'm also using a 17-inch propeller, but it's a folding prop from DJI. It's not their carbon fiber they recommend, so it can probably be attributed to that. And the maximum power I got out of my ESC was a 4.3 kilograms of thrust, which is their 85% mark. Now, there's a good chance that that's because my voltage here is sagging, because if you do the math on their watts versus amps, they're up at 24 volts roughly. So it's probably because the voltage sag. You can see they were drawing 51 amps, whereas I'm drawing, this is 45 amps, and I have a lower voltage. So probably if I went with a 7-cell battery or maybe a higher C battery, I wouldn't have this voltage sag or the voltage wouldn't sag as much. The battery was reading 25.5 volts open circuit, and under full load it was dropping about 3.5 volts to 20.9 volts. The efficiency I'm getting is 4.6 grams per watt. It's a little bit less than what they're reading here. Just a quick mention about the numbers I'm aiming for. With just the flight system, I'm looking to be around 20 pounds. Here's what kind of lift we can expect at different thrusts. So with just the flight system, I'm aiming for 20, and I want to keep it under 30, just under 30 with the head-on and the rolling drive system. So that means we're going to be running here somewhere between 3.2 and 3.8. Actually, I think it's 3.4 kilograms per motor. So we're going to be right under 75% of the full power of the motors when everything's installed. When we're running with just the flight system, we should be somewhere around 2.2 kilograms. And you can see that puts us in the 55 to 60% range, where we have a lot more efficiency. So you can see the propellers are in a folded position. I'm going to spin them up, see if they'll deploy without too much fussiness. Okay, so it looks like it depends on how tight they are. But you see, shook it around a bit, and then it came out into a properly deployed position. So we'll just have to see how well that works on the frame. Okay, so this is the door mechanism. It's a 2-action system. This is the hinge where the servo will go. I don't have the servos yet, so I haven't mounted the bracket. It pushes it out, and then that allows the door to swing out. And there will be a brace here, so that when it closes, it'll pop in like that. And it does have a tiny bit of trouble popping back in even. Sometimes the upper and lower edges are different widths out. So if I were to break somewhere else, you'd see that it gets hung up on the bottom. You can see it got hung up because I had my finger in the wrong spot. If I center my finger, it works most of the time. But to help it out, the next iteration of this door print is going to have a rounded inside corner, and it should let it quite easily slip right past that. That's why it'd be another very edge. Doesn't get caught on that sharp corner. Should be able just to slide right over. Okay, here I have the CAD for the BB8 design. The shell is built in basically eighths, 4 for the top, 4 for the bottom. There'll be some minor differences. This piece will be different on the bottom. Right now it's got a bearing insert for the motor hinge to rotate around. I've added 4 braces for the doors, so they shut against that. That'll help keep them even when it slides back in. You can see I've rounded the back edge there, so it should pop past that sharp corner pretty well. There is the servo arm. So this servo, I don't have the servos yet, that's why their mounts aren't designed in yet. But this servo will be sitting there and it'll pull on the arm and it'll close and open the door. This is going to be a winching servo, and it'll have a cord that goes up through that hole. I rounded the inside edges of that to give some relief to the string, not at the top, and it'll pull it down into the latched position. Also don't have that servo. So the propellers, they're each about 4 centimeters thick at the thickest. They're just modeled by squares right now. Then we got the motor. You can see the motor mount has a hole there. I'll drill the carbon fiber rod and run an M5 screw to hold that in. M3 is on the main mounts. I still actually have to cut a hole here for the shaft. And this one also has a hole to hold the carbon fiber rod in place. Now the door latch is a sliding mechanism. These 4 bars the door will slide out on, and then once it clears the edge, you can rotate out and open up to 70 degrees. I haven't finished designing this piece of the door yet. That's going to slide open so the doors can close back up when the prop's deployed. So let me run that animation here real quick. Hopefully it'll work reasonably quickly. Okay, so doors open up. Motor, of course, drops down and closes its propellers on the doors. The animation's not quite right, obviously won't clip through the door. But since these motors do take a 3-phase input, using a proper current loop, you can rotate them to any position. These motors are also 24 pole, so you have 12 or so positions by default, or 12-degree increments per step. And here we're going to see the doors close, so you can watch that mechanism. And there's the inside braces, and those little end pieces are Ninja Flex. These will be glued onto these will be ABS solvent, or still be acetone solvent welded onto the body when they're done. Oh, I guess I gotta add that to the rotation. That's not fix that in the animation later. So that's the body. Inside the center, this is where the drive system will go. Hopefully it'll have enough ballast. Eventually I'm going to have to find a way to have the central battery in here to act as ballast inside the drive system. And it'll have to connect down to the body with some really nice contacts to send power to the motors. So, when I was printing the door, I ran into a little problem. You can see in this picture that the prints were a little warped. The top one I printed with the heated build chamber I built, which you'll see in a second. The middle one was just with the bed at 110 degrees Celsius, and the bottom one was with ABS juice. The middle and bottom ones have they're dimensionally a little bit off. The bottom one is 0.1 of a millimeter too small, and the middle one's 0.1 of a millimeter too thick. The top one was the closest. So what I did to help alleviate this was I built a heated build chamber just using some reflective bubble wrap type insulation velcroed onto my little bottom mini, and the chamber heats up to 50 degrees Celsius while it's printing, and you can see in the final print compared to the the second to last print, this one came out perfect. It's exactly 2.5 millimeters thick, and it's got no warping. I also had to turn down the bed temperature. That was the main reason for that distortion towards the bottom of the print. 110 is too close to the glass transition temperature of ABS. So by turning down the bed temperature, I was able to get it to print right. Another thing to mention is when I did it with ABS juice, of course I got lots of cracking because it was cooled down while the top of it was too hot. So the heated bed really helped out because it's going to warp less during printing. That way it doesn't want to peel off the bed as much, so I can use the lower bed temperature and I can get rid of that distortion. And the parts are printing pretty much perfectly now. If you want to see the video I did about building the heated build chamber, just click on the picture of that video up right there. Alright, thanks for watching. I'll be back with another video in about 2 weeks. I should have about half the frame printed up by then, and I'll have the servo mounts, so I'll be able to test the door raising system, or the door opening system with actual servos, and I'll be able to test the hinging system for the propellers. Hopefully I'll also have some work done on the electronic speed controllers I'll be custom designing so that they can drive the 3 phases to the motors to position them such that you can close the propellers. Also do a test on seeing how well the propellers open on their own from spinning up in the frame. As always, thanks for watching, and I'll catch you next time.